Hi everyone. For this question, it said the motion of an object is governed by the equation of dv over dt equals to g minus kv. So from the differential equation, we can know this is our variable. Our variable is involving the quantity of t, which is time, and v is velocity. So v, velocity in terms of time. Therefore, we continue. G is a gravity, K is a constant, which means that G and K here is a constant. Then for the first part A, find the velocity V by assuming the object is start from the rest. So first start from the rest means when time is 0, the velocity will be 0. So when the object at the rest means the object do not move, so therefore its velocity is 0. So by referring to the dE here, we can see our variable is v and t, and our expression here only having v, which means that we can separate this differential equation. So this is a term of v, and we move it to the left hand side, it will become division. Then we integrate both sides. So integrate 1 over fraction, 1 over linear fraction, integrate fraction. And this one is linear, where v power of 1, we can directly get ln g minus kv over the coefficient of v. When you integrate respect to v, that's how we read from v. Coefficient of v, negative k. Then integrate from the right hand side, this is 1. We'll get t, because we integrate respect to t, then plus c. So what we need to do next is simplify until the left hand side getting v, then all the term move to the right hand side. So firstly, we move the negative k to the right hand side. It will become negative kt, negative kc. Then we unlock. Move the g to the right hand side. And lastly, divide by negative k. So when we divide by negative k, it will be positive. So I write the term g in front. Alright, so or we can write it in factor form, where 1 over k we take out. So this is g minus e negative kt. Actually, this one e negative kc we haven't simplified. So this is constant, k is constant, c is constant. So we can denote it as a. Then we substitute the initial condition, where t0 velocity is 0, in order to find out our constant here. E power 0 is 1. So we simplify this. A will be equals to G. So finally, particular solution 1 over K G minus G E negative KT, or it will be better, we factorize the G together, G over K 1 minus E negative KT, particular solution. Then, for the second question, deduce that after a long period, the object will move at a constant velocity. Deduce that means ask us to prove that when a long period, meaning when t approximate infinity, so the velocity will approximate to the constant velocity of the value g over k. So based on the particular solution that we have here, v is equals to g over k and then 1 minus e negative kt. So when we see e power of negative, rewrite it into the form of fraction where e negative is supposed to be at denominator, then now we can evaluate this approximation. So start from t approximate infinity. When it operates with the k times t, it will be also approximate infinity because a big value times with k, answer will be infinity. Then e negative kt means e to the power of infinity. Here it will be approximate to infinity. As you can see, a value power to a big number, your answer will get infinity. Then continue 1 over infinity, we substitute here, it will be approximate 0. Therefore, v now g over k 1 minus 0. So we managed to prove that after a long period of time, t become infinity, v remaining g over k. So v approximate to g over k. So that's all.